So today is Monday, the 2nd of March. I'm in Mexico and you guys are here. These are day 55 notes on adding and subtracting vectors. So here we go. We had them together. So we want to algebraically, just calculating it, and we want to see what it actually means with a picture on a graph. So let's draw these vectors. This is in standard form, so 1, negative 3. Okay, draw it there. There's the vector u. And let's draw the vector v, 2, 5. So initial point 0, 0, 2, 1, 2, 3, 4, 5. There we go. You're like me, you like rulers. There we go. There's vector v. Okay, so what is happening when we add vectors? Well, what we're actually doing is we're seeing what the force of these two vectors on each other, what the net force is. So we do use a method called tip to tail. So what I'm actually going to do is I'm going to take u, this is the tip of v, tip, tail. So the tip of v, the tail of v. So what I'm going to do is I'm going to take the tail of u and put it on the tip of v and then see what the resultant force is. So this vector here is 1, 3, negative 3. So I'm going to go to the tip of v and write the vector. I'm going to do a different color. 1, 3. Okay, and then I'm adding them together. And let's see what we get. Okay. Then our resultant vector is going to be, what is the result when you start at the beginning and you go to the end of the net result? And I always denote a resultant vector with a nice big arrowhead to tell me that is my resultant vector. Okay, and I see that my resultant vector can be expressed as 3, 2, right? X component 3, Y component 2. So this is doing it graphically. Let's do it algebraically. So what I would do is I would have the vector u, and I would write it 1, negative 3, and then the vector v, and I'm going to add them together. Adding is commutative, so it doesn't matter the order, and I'm going to have 2, 5. When I add them together, what do I get? I get r, and that is 3, 2. Exactly what happened in the picture. Okay, so tip to tail is how we pictorially add vectors, and we just combine the x components and the y components. That's how we add algebraically. Okay, operationally, maybe that's the word. Okay, here we go. Let's zoom in just a little, or not. If u is this vector and v is this vector, find, a little more challenging. What do we do when we subtract? U minus v. Okay, so I'm going to draw first u. Let's draw a coordinate plane. Okay, and I'm going to be in the second quadrant. Draw your coordinate plane so that you have plenty of room in the second quadrant. And I'm going to sketch u. V is being subtracted, so let's do u first. Negative 2, positive 4. 1, 2, 3, 4. So we've got negative 2, 4, and there's my, I'm going to draw the vector u. Okay. And let's draw the vector v in its, so uv, put the point there, but there it is. Let's draw the vector v in standard form first. Okay. In standard form, v looks like this. 1, 2, 3, 4, 5, positive 1. Okay. And I'm going to draw it in a dotted line. Here it is in standard form. But I don't want it in standard form. I want it to be subtracted from this vector. So v is 5, 1. So what I'm going to do is from here, this point, I'm going to go left 5, up 1. Let's do it algebraically first and see where we get. So if I have u, and we get negative 2, 4, and I subtract v, what's going to happen? V is 5, 1. I'm going to get, subtract. We've got to be careful. Negative 2 minus 5 is negative 7. 4 minus 1 is positive 3. So here we are, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. So I know that my resultant vector is going to be negative 7, 3. Okay, let me do that with a different color. Negative 7, 3. And so let's draw that resultant vector with a nice big arrow. Okay, and this vector, what I did, let's think about what we did. This vector right here is going to represent the subtraction of v, the blue vector. Okay, that's going to represent the subtraction of v. V is 5, positive 1. So from here, I'm going to subtract 5, and I'm subtracting 1. It's not, I think of the way I'm drawing this just doesn't show you that this is actually going down. Okay, so what I did, I subtracted 5, 1. Okay, I subtracted v. And this is what it looks like. I took u in black, I subtracted v. I got negative 7, 3. Okay, so here we go. If u is negative 3, negative 2, and v is negative 2, positive 2, fine. Here was a combination, 2u plus v. So here's what I'm going to do. I'm going to first find 2u. 2u means that we take the coefficient 2 and we multiply it by the vector u, all of its components. So 2u, I'm distributing that 2 to each component, and I get 2u is actually negative 6, negative 4. So there's u, and what I'm going to do is add it to v. Add it to v, which is negative 2, 2. Okay, and then I'm just going to combine from here. And I get negative 8, negative 2. So here we have the subtraction of vectors, and here we have the combination. We're doing operations with vectors. Okay, there we go. Now I'm going to do 2 of these with you. We'll do A and C, and please do B and D on your own and bring them into class. Or you can stop the tape and do them right now. All right, nice and easy, adding vectors together. So I have u as 0, negative 6. I have v as negative 1, 3. And I'm just going to add them together. And I'm going to get negative 1, negative 3. And that is going to be the result. So that's my answer. U plus v. U plus v. So now we've got 2 things going on in C. Okay, I don't even want to start subtracting until I figure out what 3u is and what 4v is. Let's figure those out. 3u is 3 times 0, negative 6, which gives me, distribute, 0, negative 18. That is 3u. And then let's see what 4v is. 4v, it's 4 times negative 1, 3, which gives me 4, 12. Don't forget to distribute. What I want to do is I want to subtract. Okay, I've got them nicely lined up here, so I'm just going to subtract them. But be careful with the operations. So 0 minus negative 4 is positive 4. Negative 18 minus 12 is negative 30. Okay, and that is the answer to 3u minus 4v. Another way you can think of it is if you just hate subtraction, you could, instead of doing this subtract second, you could actually multiply by negative 4, get positive 4, negative 12, and then just add. It's just 2 ways of subtraction. Okay, so please go ahead and try B and D. Stop the tape and try B and D. Okay, so you've come back. We want to, this is a little bit of review from yesterday, day 54. What we have, yesterday what we did was direction. And we said yesterday that direction is all about what is theta. Okay, and it's confusing because this might be theta prime, but it might not be. And so there's all kinds of what's really happening. We got to figure out what is theta, the distance, rotation distance from 0 degrees. So draw. So let's draw a coordinate plane. When in doubt, draw. A boat is sailing at 24 knots. There's my magnitude. Okay, so that's just the magnitude of the vector. At a direction of 50 degrees south of west. So I want to write west and south. That's what I care about. And it's south of west. So I start at west and I'm going to go 53 degrees toward the south. Okay? So there's my vector and I'm going to label it. It's 24 knots. 24 knots. That's the magnitude. This amount of rotation is 53 degrees. Okay? So that is theta prime. Okay? But we don't need this. We don't need to express this any differently, but that would be the 90 minus 53, which would be 37. But we don't really need that amount. But here we go. We really need theta. We have theta prime. We're in quadrant 3. So quadrant 3, we take 180 plus theta prime, which is 180 plus 53 degrees, which gives me 203 degrees. So theta itself is 233, and let's draw it. It's from 0 all the way around. Okay? So what we need to do is write a vector in standard form. This is the hardest part of the vector. The vector is just a, b. We got to find the components. We know that a equals the magnitude of the vector times the cosine of theta. That's the hard part, is determining theta. V is magnitude times the sine of theta. Okay, we're going to use our calculator to find that. We're going to make sure we're in degree mode. We are. We're going to say 24 cosine 233. Okay, this is negative 14.4. And then we're going to say 24 times the sine of 233, and that's going to be negative 19.2. Just take it to the 10th place. So when we write the vector, it's negative 14.4 comma negative 19.2. Does that make sense? Yeah, that makes sense. It's in quadrant 3. So that was the question. Write a vector in standard form. Okay? Let's do one more together. So we're going to, and then you can do the next two. Picture. Bird is flying 24 degrees west of north. So my two directions, it's going to be north and west. It's 24 degrees of north, so I start at north and I go 24 degrees toward the west. There's my vector. This piece is 24 degrees. It is not theta prime, right? So we got to figure out theta prime. So theta prime, this is theta prime, and 90 minus 24 is 66. So this is 66 degrees. That is theta prime. Let's just make sure we label this vector, this red vector, has a speed of 2 feet per second. Okay, that's the magnitude. We need that. So now we don't have theta, right? We need theta. So what we're going to do is we're going to say we're in quadrant 2. Theta equals 180 minus theta prime, 66. And 180 minus 6 is minus 66. Ooh, 4, 7 minus 6 is 1. 114 degrees. Okay? That is the important thing. That is theta. So now we can do our components. A is the magnitude 2 times the cosine of 114 degrees. The 2 times the sine of 110 degrees. Okay, see how I'm just doing the problem and putting the work right in the slot where it belongs? X, Y. And so A now, we'll just call this the vector. So now we're just going to do the math. Okay? So we're going to take 2 times the cosine of 114, negative 0.813, negative 0.813, and then 2 sine 114 is 1.827. 1.827. And this is the vector in standard K. Go ahead and try these two problems. All right, see you on Wednesday.